One engine every day. This is the insane manufacturing frequency of SpaceX Raptor 2. That feat is enough to overshadow every current engine in the world. But SpaceX will soon shock the aerospace industry even more with the new engine version Raptor 3. Not only more powerful in thrust, but it will also push SpaceX's engine production rate to new levels. So, how fast can SpaceX produce the Raptor 3? How can others reach the same rate as SpaceX? Stay tuned as we dive into this and more in today's episode of Alpha Tech. Produce 1 unit per day. What things in our lives are feasible with that frequency? Perhaps we often think of simple items like a chair or table. But that speeds what SpaceX is doing with one of the most powerful engines in the world, Raptor 2. In other words, SpaceX can create a monster with a power of up to 230 tons or 510,000 pounds at their factory every day. So, what do you think if SpaceX can create even crazier things like a few engines every day? It's obviously not impossible if SpaceX puts their new engine version Raptor 3 into production. We have the basis to believe is that when looking at SpaceX advances in the past, before Raptor 2, SpaceX had produced Raptor 1 for a while, from February 2018 to the end of 2021. During that period, they produced 100 Raptor 1 engines. That means in more than 3 years, it took SpaceX nearly 2 weeks to produce one engine. By the end of 2021, SpaceX switched to producing Raptor 2 engines. In November 2022, after a year, they had produced 200 Raptor 2 engines. Thus, their engine production time had reduced significantly, only about 2 days for just one engine. This was stated by Elon Musk in a tweet in May 2021. To date, the time has been reduced by half, which is 24 hours for one engine. In October, in the image of Deputy Administrator of NASA Pamela Melroy, we saw the 398th Raptor engines. That means an additional 200 engines or more have been created since November 2022. Perhaps that number is even higher because that tweet was posted at the end of October, which means SpaceX had November and December to further increase its record in 2023. So we can conclude that the speed of one engine every day is not an exaggeration. This becomes even more certain through NASA's confirmation lately last year. So how could SpaceX increase engine production frequency that fast? The answer is thanks to their simplification strategy. This strategy can be summarized in Elon Musk's famous quote: "The best part is no part. The best process is no process. It weighs nothing, costs nothing, can't go wrong." When switching from Raptor 1 to Raptor 2, we can see the overall design is much neater and simpler. Flanges were converted into welds, parts like turbo machinery, chambers, nozzles, and electronics were redesigned, and parts like plumbing, torch ignition systems, and electrical wiring were eliminated by a lot. Of course, the most obvious effect of simplification will be the reduction in mass. Specifically, Raptor 2 reduces up to 1,600 kilograms, which means 400 kilograms lighter than Raptor 1. In addition, the removed parts are all vulnerable parts during engine operation. So these upgrades help the engine limit many risks, thereby operating more reliably. The engine cost has also been significantly reduced, only about $2 million for an engine, or even $200,000 with a mass production line as to Elon Musk's claim. In particular, this smart removal does not make Raptor 2 weaker. Instead, it makes this version 25% more powerful than Raptor 1. Thanks to simplicity, Raptor production work was shortened to a miraculous level. It can be realized that SpaceX has produced Raptor 2 engines in 1 year twice more than the number of Raptor 1 engines in the previous 3.5 years. And when the above strategies are still proving effective, SpaceX simply continues applying them. According to the test result, Raptor 3 is 18% more powerful than Raptor 2. As for mass, it is only about 1,400 kilograms, reduced by 200 kilograms compared to Raptor 2. It can be guessed that Raptor 3 is much simpler than its predecessors after many other parts might also be eliminated or redesigned. When everything becomes simpler, the Raptor 3's production rate will be even crazier than now. If with the Raptor 2 design, SpaceX can produce one engine a day, why can't they create several engines a day with a simpler design? If that becomes true, it'll be a feat no previous engine has accomplished. Of course, we'll need to wait for SpaceX's official revelations. And how many Raptor 3 engines do you think SpaceX can produce in a day? Please leave your prediction in the comments section down below. It can be said that the Raptor's production rate is truly overwhelming its competitors. We can compare it with another methane engine, Blue Origin's BE4. This engine was developed in the same time frame as the Raptor, but it never can compare to SpaceX's engine in terms of production speed. Specific figures on the number of BE4 engines were not disclosed by Blue Origin, but at the end of last year, they claimed that dozens of these engines are now in production to support a large and growing demand for civil, commercial, and defense launches. But so far, we have only confirmed a few completed engines, including the two that they delivered to ULA, the one that failed in the June test, and the one located in the final assembly area in the picture when ULA CEO Tory Bruno visited the BE4 factory. Many other images show that there are quite a few BE4 parts in the factory, but it's unclear whether they've been completed or not. Don't forget that BE4 will participate in many important missions. For example, in Amazon's Kuiper satellite project, the Vulcan rocket will have to launch 38 missions, meaning Blue Origin will have to deliver to ULA up to 76 BE4 engines. Moreover, they also had to produce engines for their New Glenn. Each rocket used 7 BE4 engines. With the revealed information, it's clearly not enough for Blue Origin to solve their problems. So, how can they compete with SpaceX's Raptor? Besides BE4, there are many other famous engines like SLS's RS-25 of NASA and Russia's RD-180, which also have a much more complex design. Therefore, it can be affirmed these engines can never compare to the production speed of the SpaceX Raptor. And when competitors are looking to catch up with SpaceX's current pace, the release of Raptor 3 will be a blow to shut down all their hopes. Many Raptor 3 engines will be produced every day at SpaceX's factory. It'll be a long time before there's another engine that can do that. We may wonder why we need to produce so much. Let's see. Each Starship currently uses 39 engines, including 36 engines in Super Heavy and 6 engines in Starship. With about 400 engines, as we see in Pamela Melroy's picture, SpaceX only needs 10 flights to use them all. If SpaceX decides to increase the number of engines in the second stage, the engine consumption will be much more. SpaceX is also planning more than 1,000 launches per year in the future. Although SpaceX will apply the reuse strategy, it cannot completely solve the extremely high demand related to engines with that extremely high flight frequency. Therefore, simplification to increase engine production frequency will be extremely important, helping SpaceX meet the extremely tight launch schedule in the future with Starship. That's why SpaceX is constantly researching new versions, although they possessed an extremely powerful engine, Raptor 2. Raptor 3 is one of the typical examples of this. Before entering great missions, SpaceX will have to overcome many challenges ahead. Regardless, engine manufacturing is always a difficult task. It's a problem that every aerospace company faces in their operations. But so far, SpaceX is still doing this job well, and they can also do better in the future. When Raptor 3 production officially begins, they can create many new milestones. Once the engines are ready, that's when SpaceX's Starship fleet will fly up and break all limits to reach places humans have never reached. When it comes to mass production, we often think of factories producing everyday goods like clothes, food, or beverages, or more complex items like phones or cars. Few would consider the possibility of having an assembly line for rocket production, as manufacturing rockets is far from easy. However, for SpaceX and Elon Musk, that is entirely possible. Recently, Elon Musk revealed an impressive number regarding the production speed of Starship, reaching up to 300 units per year, no different from a mass production assembly line. This represents a significant leap in technology and smashes the entire rocket industry. So, how will SpaceX and Elon make this possible? Why does it take so long? Why is manufacturing rockets so difficult? Firstly, I want to ask you a question. Why is rocket manufacturing an inherently challenging task? Like Elon Musk said before, prototypes are easy, production is hard. Let's take a look at the members of the space rocket industry, and we can see how difficult it is to create a rocket. The largest space agency in the United States, NASA, took almost a decade to produce rockets like the Space Shuttle or the Moon Rocket SLS, costing tens of billions of dollars. Blue Origin also took over 12 years to produce the New Glenn rocket. It's not even finished yet. The giant ULA took 9 years to build Vulcan, and they couldn't even produce rocket engines for their rockets, leading to the difficulty of completing a rocket when they had to buy rocket engines from Blue Origin, causing a delay of up to 4 years for this rocket. These are some examples to show us how difficult it is to make rockets. However, the challenges of rocket manufacturing for other companies seem unable to hinder SpaceX. They even continued to set higher goals. Recently, Elon Musk, the head of the world's largest private space company, has revealed part of the Starship plan on the X social network. Specifically, Musk said, the Super Heavy booster can be used more frequently than the ship as it returns in about 6 minutes and can theoretically be ready for reflight in an hour. The ship needs to complete at least one orbit, but often several have to have the ground track line to back up with the launch site, so reuse may only be daily. This means that ship production needs to be roughly an order of magnitude higher than boost production. To achieve Mars colonization in roughly 3 decades, we need ship production to be 100 per year, but ideally rising to 300 a year. This is the response Musk gave to a user on X when he was talking about Musk's boldness in producing Starship, similar to the automotive production line, a mass production approach that a SpaceX sibling company Tesla is also implementing. And because the Super Heavy booster can be reused within an hour after, while the Starship spacecraft can only be reused once a day, SpaceX will naturally have to focus on producing Starship in much larger quantities than Super Heavy. In fact, to achieve the ambition of colonizing Mars, SpaceX needs at least 1,000 Starship spacecraft. To achieve this within a decade, SpaceX's production plant needs to produce 100 spacecraft per year, equivalent to completing one spacecraft every 72 hours, meaning 3 days for each spacecraft to be completed. A fleet of 1,000 people, each capable of carrying 100 people, can transport 100,000 settlers or 150 megatons of cargo to Mars in the first year. With the target of 300 Starships per year, SpaceX will need to meet the accelerated production demand, completing a limited number of Starships in just 30 hours. Although to date, we still do not have official information about the time SpaceX needs to complete a Starship prototype. Based on the continuous appearance of new parts at the ring yard, we can guess the surprisingly fast pace of SpaceX's work. The production speed will continue to increase as SpaceX is also building a million-square-foot factory at Starbase. In early December 2024, SpaceX's Starbase director Kathleen Lueders outlined in a presentation on expanding the facilities in Boca Chica, Texas, and the soon-to-be-completed rocket manufacturing plant named Starfactory. The scale of this project is immense. Lueders mentioned,
Those anybody that's been out at Starbase, they understand we're in the middle of a major construction activity. I mean, we have a million square foot factory coming online and being built right now. We have additional homes being built in the village. So we are really working hard to figure out how we can accomplish and achieve the goals that Elon has for us to get this factory up to speed, get a new office building up to built, get the homes built, and then be moving into this kind of the fast-paced activity of us producing and launching rockets at a regular cadence.
well, it's hard to imagine how it can grow so big. But do you remember Tesla's Gigafactory? SpaceX will do something even bigger than that. They'll turn Starbase into a place that, just like its name that Elon Musk gave it, Gateway to Mars, a place that can produce thousands of spaceships capable of traveling to Mars and beyond throughout the universe. But why does Elon Musk need to build so many starships? Because he's genuinely serious about settling on Mars. It's not a joke. It's not a scam to get more government money, though Musk won't deny that. No, Mars is the reason SpaceX exists. And now, in South Texas, Musk is getting so close to Mars that he can almost smell its red soil. Let's step back for a moment to acknowledge how crazy this is. Starship is just the upper stage of SpaceX's Super Heavy rocket, but it's considered the weirdest new spacecraft ever built. No one has ever built a rocket that can be fully reusable, and the second stage, flying into space, is the hardest part. SpaceX still has a long way to go to turn the interior of Starship into a living space for humans on the journey to Mars. But even building a vehicle that can be fully reusable, capable of lifting 150 tons into Earth's low orbit, is a marvel. It's more massive than the Saturn V rocket of the Apollo program. Compare that to NASA and its Space Launch System, SLS, the large rocket that the space agency developed over a decade. In fact, NASA has thrown each SLS core stage into the ocean after a single use. And Boeing didn't even build the engines for the rocket. It uses the main engines of the 40-year-old space shuttle. Despite this, and with nearly $2 billion in annual funding from NASA, Boeing's contractor is still sluggish in activities for Artemis. On the other hand, we can't ignore SpaceX's main legacy competitor, Blue Origin. But the reality shows that BO's rocket production capabilities are extremely poor and continuously stagnant. Their highly anticipated New Glenn rocket's been in production since 2012, expected to make its first flight 8 years later in 2020, but it's been delayed for 4 consecutive years until now. Well, we might wonder, don't they have a flying rocket? That is true, but BO also has 4 rockets throughout its lifetime, and it still hasn't achieved orbit. Meanwhile, SpaceX is still progressing day by day with their long term goal of building up to 100 ships, even 300 ships in 2024. This is insane. Honestly, when I look at the space aviation landscape, no one's doing anything remotely like this. Clearly, Musk has thought about this a lot. Elon Musk has had a lot of experience with some similar projects. He lived through production hell at Tesla in 2017 and 18, building up factories, changing processes, spending many sleepless nights, and going through all manner of mental agony. Luckily, the rewards are well worth the effort. Now, Tesla's Giga Shanghai reaches a massive production speed of up to 2,000 vehicles in a single day. Pretty impressive, isn't it? Musk then applied the well worth lessons learned from Tesla's assembly line to SpaceX, and that helps their workers avoid burnout. They'll work 3 12-hour days and then have a 4-day weekend. Then they'll work 4 12-hour shifts with a 3-day weekend. Thus, with 4 shifts, the Boca Chica site can operate at full capacity 24 hours a day, 7 days a week. SpaceX has been throwing in hot meals every 3 to 4 hours for free. The company's gearing up for a crucial test flight in early spring 2024, which is the third flight after the first 2 space flights exploded in midair. The hope with this flight is that Starship can complete 3/4 of its journey around the Earth and return to the Pacific. However, despite SpaceX's pace, there are still many skeptics. Yes, it must be said, it's pretty darn complicated. But the one thing SpaceX has shown over the last 2 decades is an increasing competence in building rockets. When it comes to innovation and rocket science, is there anyone better in the world? Probably not. Success is not assured. It's not. But when it comes to space and automobile production, history's shown that Musk pushes through difficult financial and technical challenges. The Falcon 1 rocket failed 3 times before it finally reached orbit. Tesla faced bankruptcy on several occasions. Musk has always pulled through. He now flies the most powerful rocket in the world, the Falcon Heavy, and the most cost-efficient and only reusable orbital rocket, the Falcon 9. Tesla is the world's biggest electric car company. That's all for today's episode. Hope you enjoyed it and learned something new. Please let us know what you think in the comments section below. Your feedback is very important to us and helps us make better videos for you. Thank you so much for watching, and see you next time.